Hey sports fans, it's time for another instructional video. This one's on balancing equations. We're in our chemical reactions unit, and I want to make sure that you feel really good about this skill of balancing equations, right? Don't forget the why. Why in the world do we balance equations? Well, if you look at this equation that's behind me on the board here, we're about to find out that it looks like mass is either created or destroyed, which we can't do, right? Law of conservation of mass or law of conservation of matter says whatever we start off with, atoms-wise, we have to end with the same amount. They can't disappear, right? So that's why we balance, and we're kind of limited in what we can do to balance these equations. So here's our fundamental equation right here on the board for us, okay? N2H2, and it yields NH3 over here. So step one will always be the same if you're in my class. Other people do this different ways. There's more than one way to balance an equation, but you should all end up at the same answer, right? What we want to do is find that arrow and draw a line straight down. The benefit of doing this is now we have a clear division between what we call our reactants, these over here, these are like our ingredients, and our products, what's actually being produced. On your test, one of the skills we're going to ask you to do is actually identify what are the reactants and what are the products. Remember, the arrow will always point to the products, what's being produced or made. Okay? Step two is now we have to take inventory. Remember, inventory, we're really worried about two things. What do we have and how much of those do we actually have? So this is like counting atoms. On the left-hand side of the equation over here, we take an inventory and we see we have nitrogen and we have hydrogen. So we're going to list them down here. I have nitrogen and I have hydrogen. All right? You should verify that you have the same elements on the other side of the equation. They should always be the same types of elements. If you ever come across an equation and it looks like, well, the left side has carbon and the right side doesn't have any carbon, then stop. It's probably a typo or maybe you've missed something, okay? Now we figure out how many of each one we have. On the left side of the equation, we have nitrogen and we have just 2 nitrogens. So we'll make a little note. We got 2 of those and we have 2 hydrogens. 2 hydrogens. Now let's check the other side of the equation. Over here, it looks like we only have 1 nitrogen and we have 3 hydrogens. So when we compare the left side to the right side, we see everything's unbalanced. It looks like 1 nitrogen atom just disappeared. And it looks like we created 1 hydrogen atom that wasn't there before. That's no good. We can't do that. We have to try and balance the equation to make sure that mass is conserved on each side of the equation. And the only thing we can do, this is good news, I promise you, the only thing we can do is put coefficients into each section of this equation. You can put a coefficient right here that will apply to NH3. You could put a coefficient in here that will apply to H2. And you can put a coefficient in there that will apply to N2. But that's all we can do. That's good news. That's less for us to screw up, right? So we just have to start balancing. You have to practice them. If this is not your first rodeo, then you probably already noticed there's a pattern. There are certain equations that just jump out at you the more of these you do. Take a look at it. A lot of you have seen this 2-3 combination. A 2 will never evenly go into a 3, and a 3 can't evenly go into a 2. So we find the first number that 2 and 3 will go into evenly, and that's 6. So we need to figure out how to get 6 hydrogen on each side of the equation. Here, a coefficient of 2 multiplies across this whole part of the formula and gives us 2 times 3, that is 6 hydrogens. To match that over here, we put a coefficient of a 3 because 3 times 2 gives us 6 hydrogens. Remember that the coefficients do not apply across the yield, and they do not apply across a plus sign. They only apply to that section of the equation that you're actually putting the coefficient in for, right? Now this is fantastic. The hydrogens are now balanced, but this little 2 over here kicked an extra nitrogen. 2 times 1, this is actually 2 now, which was a good thing. Now our nitrogens are balanced on each side of the equation, and our hydrogens are balanced on each side of the equation. What about the other coefficient, Mr. Call? Oh yeah, if you don't put a coefficient in, if it's blank, it's automatically understood that it's a 1. Boom. So because the base equation, the part that's written in blue up here, is the same for every student, the only part that you'd have to turn in for your answer to show that you've accurately balanced this equation are your 3 coefficients, right? So on a test, you'd record your coefficients in order from left to right. are 1 right there, 3 right there, and 2 right there. Okay, that shows that we have balanced that equation, that the law of conservation of mass has actually been conserved, and so we're good to go. And that's how we balance equations. If this isn't like really great, if you don't feel warm and fuzzy about this, do some more reps. Take inventory, mess around with coefficients, and you're going to start to see patterns, and you're going to get awesome at this. All right?